Hello everyone. In this video I'm going to discuss how to build this kind of web application, and this is for COVID-19 detecting using X-ray images. And first of all, I would say that this is not an accurate method. This is only for educational purpose, since this is going to give positive results for other diseases as well, like pneumonia, SARS, MERS, those kind of diseases as well. So my actual target is to discuss how to train a convolutional neural network for this kind of application, this kind of a classification application, and also how to integrate that trained neural network model into a web application using Python and Flask. So first of all, I will show you the project folder, and then I will then explain how we can implement this project. So this is the project folder, and you can see that here we have several folders and files. So these are the three main codes that I'm going to use in this code. So this is actually for the dataset creation, and this is for the data preprocessing, and this is where I'm going to train the convolutional neural network. And this folder contains the web application. I will explain it later. And this contains the dataset, actually the COVID-19 negative images and also the COVID-19 positive images. And also for this purpose, I'm going to use two main datasets. I will explain, and I have the whole dataset files here as well. So using these two main datasets, I'm going to create my customized dataset where I have the COVID-19 negative images and COVID-19 positive images. So I will upload this folder into Google Drive, and the link will be posted in the description of the video, so you can download it and run it your own and get the results. Okay, so now I'm in the first code 1.0, creating dataset. So in this implementation, I'm going to use Anaconda distribution as usual, and here the Jupyter notebook is used, and I will post the modules, the libraries that I'm going to use for this project as well, so you can install them and run it your own. So for this purpose, I'm going to use mainly two data sets, the COVID-19 chest X-ray data set and the pneumonia data set by Praveen in Kaggle. So I'm going to show you these two data sets. The first one, so this is the first data set, and here you can read the description and get the idea. And in this images folder, we have the images, and also so we have several images here, and also we have to use the metadata.csv file to extract the actual images that the COVID-19 positive images. So this CSV file gives the file name as well as yes, you can see. So you can see here it's giving us the file name as well. So we have to extract, filter the images which are here with the COVID-19 positive category, right? So COVID-19 positive category, here SARS, COVID-19 and other images are here as well. So we need to extract the COVID-19 positive images. So I will explain how to do that. So you have to read this metadata CSV, then we have to extract or filter the images, COVID-19 positive images. And the next data set, the pneumonia data set by Praveen. So here you can download it directly from the Kaggle data set, and this actually contains two types of images, pneumonia positive and normal images, that means pneumonia negative. Actually this data set is not connected that much to the COVID-19. This is only having images with pneumonia positive and pneumonia negative. So what we are going to do, I'm not going to use the pneumonia positive images here, but I will use the normal images, the pneumonia negative images, as the images for COVID-19 negative images, right? So I'm going to extract the normal, the negative pneumonia negative images as the normal images for my implementation here. So those are the two main data sets. So in this code, I'm going to write a small Python script where we can extract the COVID-19 positive images from this COVID chest X-ray data set, and normal, that means pneumonia negative images as the normal COVID-19 negative images from the pneumonia dataset. So those two classes will be, or those two categories of images will be used to train my neural network in this project. As you can see, we have two datasets downloaded here. So this one actually contains the images of COVID-19 and SARS and other stuff. So we can open this CSV file. The CSV files gives us the COVID-19 positive and SARS, and you can see several categories are here, right? Not only COVID-19, but this is the category, and we have to find the image name. You can find the file name from here, right? So you can see the file name here in this column, right? So what we are going to do, actually, I'm going to first read this CSV file, and I'm going to check this column, and if the image COVID-19 positive image, I'm going to read that file. I'll read that file from the file name here, and transfer it to the dataset I have, the dataset folder, the positive images folder, right? And similarly, this dataset, the second dataset, contains the pneumonia positive and pneumonia negative images. So in this one, I'm going to check the label, and if the label is normal, then this image will be loaded, and that image will be saved in the dataset folder and the negative images folder, right? So that's how I'm going to collect my dataset from these two datasets. So I'm in the first code 1.0 creating dataset, right? So first I'm going to give the data path 1 where COVID-19 images dataset is situated, and that's data path 1, and that's already. Then I'm going to give the dataset path where I'm going to save these filtered images. Then I'm going to get the folder names from the dataset path. So there will be two folders, COVID-19 negative and COVID-19 positive. So I created those folders, and then the metadata CSV file will be read from this folder, right, the dataset 1, and then I'm going to check the indexes for the row numbers. Let's say the row numbers where COVID-19, where the so in this data set, I'm going to check where the finding column, right, the finding column. So you can see the finding column, I have extracted it from here. The finding column, when the finding column is equal to COVID-19 or SARS, so I'm going to get the both here since it's quite same. Then I'm going to get those indexes. So this is actually getting the row numbers where in the CSV file where the finding column is COVID-19 positive, right? So then those indexes, I'm going to take the image names of those positive index. So that means we can make sure that all these row numbers contains the images of COVID-19 positive, right? Then those image names will be loaded here. Then I'm going to go through each and every positive image name, and then I'm going to read it using OpenCV imread function, and then that image will be written into the dataset path. So dataset path will be dataset, and category 1 basically will be the COVID-19 positive folder. So all the images extracted from here will be written into the dataset COVID-19 positive folder. Then in the next section of the code, I'm moving to the second dataset where pneumonia positive and pneumonia negative images are there. So similarly, I'm going to read the metadata CSV of that dataset, and I'm going to take the label column, right? The label column as the findings, and the image names. I'm going to take it to the image names. I'm going to take it to the image names, and then I'm going to take the negative index, the row numbers of the pneumonia negative images, and those will be taken here. Then I'm going to get the image names of those COVID-19 negative images. Then this loop is going to go through all the images one by one and read those images, and those images will be written into the dataset and the COVID-19 negative folder. So now I have two folders, mainly COVID-19 positive and COVID-19 negative. I will show you. So here you can see the dataset folder, and if you go to the dataset folder, we have the COVID-19 negative images extracted from the pneumonia dataset, and the COVID-19 positive images extracted from that other dataset, right? So we have the two categories and dataset. So here we have around 1600 images, and for the positive COVID-19 positive images, we have like 500 images. So now we are going to perform pre-processing for these datasets. I mean both the categories, and create the actual dataset that we are going to apply for the convolutional neural network. So now I will move to the second code, data pre-processing, right? So now what I'm going to do, I'm going to move to the folder dataset, and from there I'm going to take the two folder names into the categories os.list directory. Basically go to this data path and read the folder names, and categories will be, as you can see, I have printed it here, and two folder names, COVID-19 negative and COVID-19 positive folder names. Then I'm going to create a label array where the labels will be 0 and 1, since we have two main categories, so 0 and 1. Then I'm going to create this dictionary where COVID-19 negative is 0, COVID-19 positive is 1. So now the category 0 is COVID-19 negative and category 1 is COVID-19 positive. Okay, so then what we are going to do, we are going to go for both categories in this for loop one by one. The category will be, the first time the category will be COVID-19 negative, and this loop will run for COVID-19 negative folder, and I'm going to create the folder path dataset / category. So that means dataset / COVID-19 negative. Then all the images names in that folder will be loaded into this array, and again I'm going to go image name one by one here. So we have like for the negative we have like 1600 images, so this loop will run around 1600 times. So then the image path will be loaded to here, and the actual image finally is going to be loaded here. Then this image will be converted into gray color using the convert color command in OpenCV, and then resize to image size. So I'm going to use 100 here. Actually this is there is no reason behind that. You can use your own size, but I have decided the intermediate value. So when you are going to increase the image size, the quality of this prediction will be increased as well, but it's going to take a high amount of time to get the prediction and also for the training. And so it's going to convert it to a common size of 100 and 100. Then we have an empty list called data. So the resize image will be append to the data, and the target we are going to append as 0 and 1. You can see the dictionary we are using. So if it is a negative image, this will be 0. If it is a positive image, this will be 1. So image and the target, whether it's 0 or 1, will be appended to data and target respectively. And I have used a exception handling method here, since sometimes these images might be corrupted or this image might not be available. That kind of issues might be raised here. So I have used exception handling here. So if there is any exception raised, it's not going to terminate the code, but it will give a exception and continue reading the images and creating the dataset. So finally, I'm going to normalize all the images. So you know all the pixels of a single image having a range of 0 to 255, since this is a grayscale image. So I'm going to convert it to 0 and 1, in between 0 and 1, all the pixels value to 0 and 1 by dividing it by 255. Then I'm going to reshape it to data shape. That means how the number of images, 100, 101. This is required for the neural network, since we have to give it like a 4-dimensional array in order to train the neural network. And the target will also be converted into a NumPy array. Then it will be converted into the categorical form. I have explained this earlier as well. So the categorical form, then we are going to save those two arrays as data.npy and target.npy in our working directory. So now we will move on to the neural network training code. So this is the code that I'm going to use to train the neural network. As you can see, we are going to use a convolutional neural network, and this is a bit new type of a neural network where I'm going to use parallel convolutional layers here. So I will explain. So mainly the neural network architecture is like this. We are going to input a image of 100 and 100, and then it's going to go through this convolutional neural network, and finally it will be a classification type neural network where we are going to get two neurons at the output layer, and they are giving like COVID-19 positive or negative, right? So this is going to actually give us the probability of COVID-19 positive and COVID-19 negative. So first of all, I'm going to load the data set, the previously saved data set from the last code, the data and target. And this is the neural network architecture. We are using Keras API to implement this neural network architecture, and the TensorFlow is the actual backend we are using. And this is how we are going to create a parallel convolutional layer. So here you can see now we have like 128 3x3 kernels, and 128 5x5 kernels, and 128 128 7x7 kernels. So those are like parallel kernels. So we have like 128 into 3. So that much of parallel convolutional layers are here. So in order to create this parallel neural network, I'm going to like mention how many the kernel size here, and this loop will run 3 times for 3, 5 and 7. Then for each kernel we have like for each parallel layer we have 128 kernels, and the kernel size will be k. So first time it will be 3, 5, 7 likewise. So we have 3, 1, 2, 8 parallel kernels, right? So then finally we are going to append those kernels, those layers into one kernel. We are going to append those 3 kernels into one layer, and finally we are going to create a sequential layer and get this convolution, the parallel layer here, and the first layer will be a parallel layer. Then thereafter we have a concatenating layer where we are going to concatenate all these convolutions coming from this layer. Then thereafter we have a general convolution layer of 64 kernels, 3x3 64 3x3 64 kernels, and again and a general convolutional 2D convolutional layer of kernel size 3 by 3, and we have 33 kernels. Then finally we are going to move to the dense layers. So then we are going to flatten all the convolutions coming from this layer, and finally neurons 1 to 8 dense layer, then 64 neurons dense layer. Finally we have the output layer where we have 2 neurons for positive and negative. So this is the neural network architecture. You can use the model.summary to view the neural network architecture as here, and also we have used dropout layers in order to minimize the overfitting of this neural network, and also we have used softmax as the activation of the output layer, since we need to get the probability of COVID-19 positive and COVID-19 negative. And we use categorical cross entropy loss, which is the commonly used loss for classification type problems, and Adam as the optimizer. So then we are going to split the data set into training and testing, and 10%, as you can see, 10% will be going to the testing and 90% will be going to the training, and we are going to train the neural network using 90% of the data. And also I have created a model checkpoint. So by this, what will happen, we are going to monitor the validation loss, and we are going to save all the neural network models here, and the condition, if the validation loss is less than the previous epoch, then only these models will be saved. So we are not going to save every model after every epoch, but only the best models will be saved, and we are going to maintain it using the minimum validation loss, right? So then we are going to save best only, and the neural network will be trained for 20 epochs. You can later increase the value and see whether the neural network is increasing its accuracy. And we are going to use from that 90%, 10% we are going to use as validation data, and this is the training history you can see. So it's performing well, as you can see. Now it's increasing the accuracy to 97, but you can see the validation accuracy is also 99. So this is a quite good model, as we can see, and the validation loss is also decreased. Sometimes it's bouncing, but overall it's a good model, as we can see. And then these are the two graphs for the loss and the accuracy. So you can see it's not showing that much evidence for overfitting. So this is a quite good model. We can see the accuracy is the loss is decreased with the epochs, right? So this is a quite good model, but you can train it for more epochs and get a higher accuracy or lower loss as well. I have only trained it for like 20 epochs. So this is the accuracy similarly. So accuracy has increased, and the best thing is that the validation and the training loss and accuracy are quite similar. That's a good indication. And also the testing accuracy, we are going to test the neural network model using the testing data that we kept, like 10% from the whole data set, and we are going to get like 99% accuracy. So that's indicating this is a quite good model. And also we have achieved a loss mean squared error of 0.02. Okay, so that's the model training, and then I'm going to implement the web application for this model. I'm going to integrate this saved model, and then I'm going to integrate it with the web application in the next video. So thank you very much.